I'm Christian Knudsen, and I'm the technical manager of IK Group. And I've been working for this company for many, many years and done a lot of projects. And today we are going to present one of them. And you, boss?
Hi, everybody. I'm Bozidar Sevik. I'm a project manager in IK Norway. I've been in this company for, 8-9 years now, and been basically through pretty much all stages and all phases, being a project engineer, senior lead engineer, and now project manager. And I've been involved in this project where we're going to discuss today.
Okay, so let's jump onto the presentation.
All right. Start.
Yes, everyone. So today we are going to talk about a repair project we have done on a 1500-meter water depth field. It was a 12-inch flow line with a big crack, actually over 180 degrees circumferential. That was repaired, and there was quite some challenges related to this. So this will be this topic. We have about 30 slides, and we assume we are going to talk for about 30 minutes. If you in the chat, just if you have questions, please put them into the chat box, and we will then collect them afterwards. These questions will only be seen by us, and we would like to do that at the very end of the presentation.
Okay, so I see in the chat right now that there is some feedback. Okay, we are told that we look great, so
yeah, come with some news, guys.
Come with news, yeah. All right.
Okay, but and I think I'll also spend a couple of minutes about IK. I guess most of you know us, but we are still a company that is focusing on repair and modifications of old existing pipelines. That is really our main subject. We typically work deep water with remote technology, and we also typically work with bespoke solution. We are located in Norway, Stavanger, with about 80 people, which is about 50-50 engineers and mechanics. And our clients are in the North Sea, but also worldwide. So the project of today, that is a West African project. And we have been several places over the last years internationally. So I think we just jump onto the presentation and start telling about what this is. And here you can see the start, the unfortunate start. This is a connection between a 12-inch flow line and a PLEM, a pipeline end module. And what you can see here is the glass reinforced polyurethane that is covering the structural support of the 12-inch pipe onto the PLEM anchoring. And as you can see, there is a significant crack here, which is going through the coating, of course, but it also penetrates into the pipeline. At this stage, the client didn't know what sort of crack was underneath here, but it was big because the pressure went down immediately after it was revealed, and the production had to be stopped immediately. So we were contacted and tried then from day one to see how we could solve this. Just to give you a little more understanding of what we are looking at. You can see here, this is what this connection looks like when the glass reinforced polyurethane has been removed. I don't know if you see my mouse now, but this...
I don't.
No, okay, right. That means that you can see there is a pipeline covered up with 100 millimeter 5 LPP. And then we have this swan neck, which is also covered up. After this has been done on the vessel, I assume they would do this welding. They will cover up the entire junction with 100 millimeter minimum GRP, which is the glass reinforced polyurethane. This system is welded onto the pipe with 2 fillet welds between this Doppler pipe. And that, as you can see, those 2 360 degrees fillet welds. and the one to the left is really the issue of concern. What happens with this pipe is that it has been subject for vibrations. Actually, there has been a large erosion of several hundred meters to the left. It has started to vibrate, and of course, a fillet weld between a support pipe and a pipeline is not really the best way. So it cracked open, and it turned out to be more than 180 degrees when you got later into this. So the client is left with a pretty significant problem. There are loss of pipeline possibilities, loss of production, hydrates can come. What shall we do? So we were contacted, and when we was contacted, we very quickly found out that there has to be a temporary repair to try to save this pipeline from hydrates and from being completely cut off, savaged. So as you can see on next here, we in a way decided to do two things with the client temporarily as quickly as possible. One was to try to seal off that leakage, which is a crack, and to seal against isolation material is not really the way to do it, but this is a tough and strong, so that could be possible. And then we were also agreeing that we should put on a compression load to stop any further propagation of this crack. So this was kind of the way set forward, and now the project manager has to tell us how he did it. So I leave the word over to Boss, and yep, please.
Yeah. Okay. So, yeah, you didn't touch upon on this temporary solution and permanent repair solutions. I mean, they're mentioned here, but obviously, client wanted to go forward with fixing the problem as soon as possible, while at the same time there was significant kind of a background work being done, scanning subsea metrology and all that sort of stuff. So we were trying to understand basically how we could fix it. Obviously, it's not a clean case. You don't know what's underneath the GSPU, and you can only see the crack and estimate it based on some images and stuff like that. But we had already employed some ideas from before. So here, Christian, I don't know if you touched upon these values here, tensile strength of the GSPU and shear strength. So we had some limitations when it comes to what principles we can employ here to basically seal it off.
Yeah, but in general, this is very strong material. It's like wood, more or less. So there are possibilities, but it's far away from steel, of course.
Yeah, and especially at the 1500 meter depth, right? So
yeah.
it gets compressed very hard. There's ambient pressure of 15 megapascal. So, and of course, there's always some discussions about this bonding between this type of coating and the pipe, right? So if that's been compromised, which we will find out later, then we have maybe another set of issues, which again we'll discover later. But at this stage, we are only assuming, and we have some ideas flowing around. So here is, let's say, first, once we assembled the team and we started thinking about how to prevent the further growth of the crack that will come later, but to seal off whatever has been exposed, and to prevent any ingress of water further and any sort of pollution. And basically we came up with something like this. That was the initial concept. I remember we even had internally some kind of a competition between the concepts. So this was the one that won at the time. And in general, we were focused on fast track delivery. So that was always kind of a premise, fast track delivery. So this clamp, when you see, or the sealing device, it's a sealing device at this stage. Later on, we give it a name, and then it evolves into something else. But this one employs a principle that's actually been used by IK on several occasions, and it's the whole idea is compressing the elastomer or compression packer into the, or around the seal and into the seal. So there's several elements. All of you pretty much know how the compression packers work. But in this time, we have maybe on this slide, next slide, I'll show you. So to the right, sketch to the right here shows a typical, let's say, section of a pipe, straight section, where you could potentially have this one shows GSPU and a polypropylene coating connecting to it, which was the case basically in our job. But then you have a straight section of a pipe, so no need for so no obstacles when you want to compress the packer. Don't you agree, Christian? So when you look, that was the main reason why we had to employ something that we haven't done, let's say, at that stage yet. So what's happening here? If you look, you have this step. So the section that's molded in GSPU has a certain step here, and the crack was, as what we could see from the images, was very, very close to the wall. So if you would employ this principle, as you would compress the packer, you would just push yourself away from the crack, and we couldn't afford that. We needed to be sure that we can stay in this area here. So what we designed was some sort of semi-structural clamp, which basically was not structural. What it provided us was, on this image here to the right, you can see a platform that we gripped onto this GSPU, holding us in position while we compress the packer and extrude it circumferentially into the crack. So that was a way to go. So this one says issues. I would say challenges. Issues sounds a bit harsh, but challenges. So we had some ideas here. So and we were learning through the process and figuring out how to do it. And that's why we previously internally we used the name patch clamp, because we kind of see it as a patch, which would be regardless of where the crack is or where the defect on the pipe is circumferentially, this method would seal it off. Maybe discovering a little bit of technological ideas here, but so that's why we call it patch, because when you're wounded, patch works the best, directly applying pressure, right? In this case, the crack turned out to be big and wide. So, yeah, so there are some parameters here showing the water depth, pressure, and obviously when you compress the packer, you need to have in mind the operational pressure, which was 40 bar, plus pressure in the packer that needs to be compressed basically to withhold this pressure that's potentially going to be there.
So, boss, the 40 bar operational pressure was just for the sort of salvation
exactly
period. 200 bar is what we have to repair it for finally. 40 bar is just to put in methanol, etc., to save it from getting hydrates.
Exactly. Yeah. So I don't know if you want to talk about this, Christian, but yeah, you just actually said it. Yeah. When we did this temporary solution, we had in mind this flushing with methanol just to avoid hydrates building up until the permanent repair comes. But that's all you said now. So moving on to the next slide, we also now you see a little mock-up of what's actually down there. So this gooseneck, what Christian mentioned on the plan, and this junction here with this little skid that you're about to see a bit later, this steel skid that's actually covered with this GSPU as well, holding holding it and preventing further movement. So we realized that only with this sealing solution, we would still be in danger for actually even further degradation, further decay of, and possible even separation. So we needed to come up again with a solution that will structurally reinforce the entire joint here. So we call it structural reinforcement system, or short SRS, got its name. And the system was based on grabbing onto the back of this little skid that I just talked about, and grabbing again with the slips and teeth in the front, connecting the pipeline and the PLEM side of it. And that's, again, now we're in concept stage, and let's see what happens. So the concept was okay, accepted. We, on a short notice, we just started and full on, and we started doing some tests on different harnesses of packers, and trying to actually estimate the crack width, and doing all sorts of basically gripping tests as well, just simplified, so we get some knowledge, really. And we concluded, so that was really valuable test and pretty efficient, where we actually realized that even with the gaps, potential gaps of 3, 6, 10, and even 15 millimeters, depending on the pressure of compression and extrusion, 85 sure turned out to be the right hardness of the packer. So that was good, and then we moved on further and built the actual clamp. So when we built the clamp, we also built a little test rig that represented everything. Really was made in just regular plastic, if I'm right. It was just a POM. What's POM short for?
I wouldn't know, but we tried to find a plastic with the same properties as the existing, and I think we succeeded pretty well.
So again, this is a let's say quick solution for the temporary solution again. So further on in the project, we'll actually do a much more detailed test rig. So here you can see the patch clamp that I was just talking about, actually built, and on to the right you see the crack that we estimated and drilled the hole through the plastic, and on the other end we had the fitting and everything. But on the top here you see the marks from those teeth that actually established a platform for the compression packer to be compressed around here. So you had 4 of these on each, 2 on each side. And then we built a bigger test rig. Then we represented this gooseneck and had the entire structure actually built, welded, just like based on the drawings from the client. And on top of that, we had GSPU cover molded to the actual specs. So in the meantime, as I said in the beginning, we were being fed information constantly. So there's a big job really being done here, with the client being super involved and marine contractor being very helpful. So there's synergy and a constant flow of information, really. So that's why we were able to get all this information and build a test rig that would be actually representative, and that we could go offshore and do the job. So with this test rig, we were able to check the material properties beforehand of the GSPU, so we will know what we're dealing with. Obviously, GSPU, some of you, I see some names here that I've actually even talked to in this process. So so you know about GSPU being submerged for 15 years or 20 years, doesn't matter, underwater, and material properties in general, degradation of material, and so on. So we took all of that into equation, and then we used it for installation testing and to do the load testing to check whether the structural reinforcement system works. So on top of that, we did the pressure testing, but that was another thing. So moving on to the next one. Now it's more or less what I just mentioned. So we use the test rig to install the patch clamp to verify it works. And then we used on top of that to install the structural reinforcement system together with the structural clamp on top. So all of that was tested and well documented. So the risk was there, but the risk was basically managed and was minimized. So we were getting ready to mobilize the equipment and to go offshore and to actually do the job. You can see actually on these slides the real equipment during the testing in the workshop in IK facilities. So those were, again, very well documented. It was a very successful test, just what we planned, because on previous slides we mentioned there was an FEA analysis done and a bunch of other analysis that accompanied us. So we were happy to with the results after the testing and installation method as well. Here you can see some slides from the offshore operation. And just to cut the story short, it was installed successfully. I was there. All elements were really followed, procedures, and everything worked well. And I'm not sure if in the next slide or where we talk about permanent repair. Yeah, but let me go just once again back. Christian, do we talk here about? Do you want to say something or?
No, I'm ready for the permanent.
You're ready for the permanent.
Yep.
So I'm just, yeah, you can see all elements here. At this stage, we were very happy with the installation. But now when you talk about permanent repair, we'll probably meet those stories together, temporary and permanent repair, into the final story. So let's hear about the permanent repair from you, and then I'll jump in a bit later on. Is that okay?
Yes, thank you, boss.
Yeah.
So now we are entering into the permanent phase, which we have been in all the time, actually, because we started off at the same time, more or less, but we didn't really kick it properly off before we had proven that we could install the temporary solution. So up left, you can see the temporary solution where we have the orange clamp that is being squeezed with about 100 ton towards the plem in order to get compression load, and the sealing clamp is preventing water to enter into the line. So in a way, we have a safe situation, but we do not have a permanent situation, and we do not have a situation for operation. So if you look to the clamp to the right bottom, you can see that we have a blue structural sealing clamp, and then behind boss and me, you can see a purple clamp that is going to be a permanent structural clamp. So what we are really going to obtain now is to have a system that can take the pressure and can take the loads you get permanently. And those loads are significantly higher than what we see in this intermediate period. So actually, if you jump to the next, I'll show you the solution. That's what it ended up with. And boss will talk more about that afterwards. I will talk a little more about how we got there. Not how we got there, but how in a way we had to plan for it. But what you see here now is a structural clamp that is being installed onto the steel surface, and it's being torqued up here to get the right compression load towards the plem. And here you see a structural sealing clamp that is both giving sealing and structural reinstatement of the cracked location. So let's step a little back and see what we have here. Because we now suddenly enter into the real life with a lot of different load cases, because a system like this will see very different loads when it is in a phase of being cooled down or heated up, pressured up or pressured down. And you get all these cases because you have to assume that the line can be fully pressurized and cold, and fully pressurized and hot. And by all those combinations, you get a lot of load scenarios. I think we got 5 different scenarios we had to cope with. And we now have a system that is really not prepared for this. If you look at the bottom sketch here, you can see that we are going to only have one weld left between the support structure and the pipe. Then we have a crack location, and then we have this structural clamp. This is really what we have. So if we had repaired the crack location 100%, we would still have a problem because we have removed, or we are going to remove, one of the support welds, and one weld is not enough to take the load. You may not understand this, but you will see it in a minute when we explain further. So we now have a system response that is a little above what we normally do. And we must admit that we were fighting quite a period to get this calculated and sorted out. And actually we did it in the end, but that was pretty tough job actually, because this is not any standard way of doing a connection. You just have to, in a way, approach it as a completely new system. And to do this, here you can see the system again. We systemize it, and then we put in spring elements for the various elements, and we are putting in pre-tensioning, and then we are playing with this. And as you can see here, we have the pipe, and to the right you have the anchor point, and all the loads are going from the anchor point to the pipeline in different ways. So the load comes through, for example, if you have a very cold pipeline, for example, you will get tension load in the pipe. Some of the load will go through the pre-tension stages, some will go through the new clamp into the single weld, and then everything will go into the anchor. And I can't really talk in more details about this because this was analysis, but I will go into a little more details with you. And in order to get a proper connection here, you needed to take both some structural load and the complete sealing. And there was very limited space. And here we have what we call the compact integrity clamp. And this is a pretty smart device because it is compact, it has a sealing element in the middle, and it has teeth slips in both ends, and it can be set from one side. And actually this is an invention we have done that is patented. Otherwise I wouldn't have shown it to you. And it's a genius way when you are working in limited spaces, because here you can actually set structural slips on 2 sides of a damaged area with access from one only, and that was crucial for this project. If we hadn't had this system, we could never have repaired this location. So as you could see from previous, it takes all the loads, but when you have limited space, there are limitations with the capacity you can take. Here there is a little more details, but the way it operates is that we are torquing these bolts, then we are setting the slips and the packer. We are setting the packer to a defined load. Then afterwards we are setting the bolts with the very same tool. We have a tool here that both can turn the nut and the bolt, and then we are setting the slips. So by this, I know I'm very specific, and I think I'm only for the specialists of you. If you are here, John, I'm sure you are listening interested now, because we get, by this very same bolt, we can get 2 different setting loads on the packer and on the slips. By playing with the angles, here you get the right compression load down on the pipe, so you can adjust both parameters individually. And that was crucial for this job. I think I'll leave it there. So I think I'll soon will leave the word to Boss now, because it's very simple to sit and make these sketches, but to make this work is quite a challenge. But I'm just showing you this because here you will see that this is the location we are going to work on. Today, or before we got there is a huge pipe here with stiffener plates and a crack going almost always around. And we have to grind and machine away everything underneath a structure in order to get this clamp in. And then we have an angle here. So please, boss, explain how you did this to us.
Okay, so you want to leave it at this slide, or you? No,
Yeah,
it's fine.
yeah.
That's fine. I can
Yeah,
continue
you can
from this one.
Yeah.
Now you explained. So this is we're also showing you a little bit of evolution here, and this system has been in a kind of in a pipeline of being patented for several years now. It's a patent, so we can talk about it. But we call this. It belongs to a family of compact family, or so to say, compact integrity clamp, right? So it's combined sealing and structural clamp, as Christian explained, and it's completely set only from one side. So when we talk about this, who could potentially ever want this? There's so many of these pipelines that are actually butted against a certain structure, or that you don't have access to other end, which you would normally have on a straight pipe. So that's when you actually wish to have a device like this. So this is what we see here is basically the clamp body that's and compression rings from both ends, and on the front we have these special torque tools or torque wrenches, a little bit custom made. What Christian previously mentioned for setting of both slips and packers at the same time. So normally we know how these clamps work. We want to at certain point we want to push, and sometimes we want to compress, sometimes we want to tension. So that's where we did a little trickery here when we are setting the bolt first and then doing the nut. So details, of course, can be provided later, or maybe in the questions if you're not really sure how it works. But now we look at this sketch or image. It's not sketch; it's a real photo from offshore operation, and this is really interesting. Now you're seeing the machine, you're not sure really what you're seeing. So when we talked about this, you can see this crack on the photo. But in order to get down there, and by now we have all that information, we have so many assumptions. We have an actually really good idea of what we want to do, and we need to basically like methodically pick this apart. So take away everything that's in our way in order to get to the pipe. We have a clean picture, we have an idea what we want to do. So in order to do that, at this step, we needed to build some machining tools or subsea milling tools. So what you see here is we just call it simply XYZ tool. It has standard milling head that you would find in a machining shop. We fiddled with different types of milling heads, but it has 3 axes that it can work with, and it's fixed on a platform on this structural reinforcement system, if you remember that I mentioned in the beginning. So it's the whole tool is docked there, and then we can control it by ROV from the ROV panel. And the beauty about this is that we had a really extensive test program in both in IK and with the marine contractor inside the pool, where we actually tested the parameters to the detail that is rarely done on shore. But so we exhausted all options, tested, and realized that we needed to have interchangeable tooling subsea. So what you see there, this little red plate there, that's an interchangeable milling head that can be for various positions of the tool. So on the next slide, I guess it's on the next slide, you'll see really what we needed to do here. So we needed to cut away the pocket where we want to install the compact integrity clamp, and mill away a lot of steel and GSPU on one end, and then on the other end we needed to mill away polypropylene coating with the tool that you see right here. So that's another part of those tools that were basically custom built for this operation in order to get to the bare steel pipe. So we call this one at the time Orbital coating removal tool, because the tool actually is rotating around the pipe 360 degrees with the, again, similar type interchangeable milling heads and brushing heads and whatever is necessary really to actually remove the thick layer of coating and brush away the final, this FB, this nasty green hard layer. That's the thinnest layer, the hardest layer. So basically we were able to control the coating and removal to the point as a matter of fact, we have one tool right now in the field and I'm getting images, and it's the surface roughness is basically what we want it to be. That's the level we managed to get with these brushing tools. So yeah, here you can see this is the area that we want to clean out for the compact integrity clamp, and then to the right, further to the right, we wanted to clean away the coating on the pipe where we would grip with this structural clamp. And here is the result of the cleaning. So if you look at the cutout, you see that there's this really thick steel tubulars that, I mean, you can see that they're tubulars now, but they resemble, you see this sandwich of steel. There was a heavy, thick, actually, plate connecting those tubulars from on each side to the doubler plate that Christian mentioned earlier, which all needed to be removed. All the welds needed to be machined away. So you can imagine what kind of precision it requires, and you know, considering all subsea visibility and everything like that. So in order to get to the crack,
we should reinforce that this is not in the workshop.
This is subsea.
Yeah, it doesn't look like it, but yes, it is.
Well, yeah, you could maybe recreate this in a workshop, but I think if you look closely, you see the dirt, so must be underwater. So you can see here. Now we got to the crack. There was some additional activities regarding the pipeline being lifted further away in order to secure the straightness of the pipe as much as possible, but I'm not going to talk about that. So and we were right. What really amazes me with this job is that all of these assumptions, all of this metrology, subsea being done, scanning, models being implemented, calculations, and we were really right what's underneath that GSPU coating. And the crack was about 10 millimeters, and the crack was about 180 degrees. So we couldn't really measure, but that's all the assumptions were right. And we had all the dimensions, all the distance. We knew it's going to work. So because we tested it in the workshop. Yeah. So if you go next slide, we show the installation of the actual compact integrity clamps. Now we're looking from the other end, right? So this is the GSPU block that we machined away, and installation of the compact integrity clamp. So the clamp is pushed all the way in. Slips are properly positioned. Elastomer pecker is properly positioned right above the crack. So we know all this by now. And the clamp is being set by the torque tools. And here in this image, actually, I'm pretty sure this is the clamp is completely set because there's no torque tool wrenches in the front. So all that is being removed. Actually, it looks like they're being, taken up by the ROV on this image. So the clamp is set. That's it. So structurally, the clamp is set. Now, the next stage was to bring down the structural clamp that would be gripping on the actual pipeline and connecting the structural reinforcement system and connecting the pipe tensioning or compressing the correct location to prevent further, to prevent whatever it's supposed to prevent, right? That was it. I don't know if we have, Christian, if we have inserted some of the images after it was installed, or was this the last slide? No.
This is the last.
Yeah, if you want to look a little bit more into this one, it's no problem. After that, there was a successful pressure test done, and it was considered a successful operation.
It was definitely successful because the pressure test was done as planned.
Well, it's
and it's yeah. So, but I think now we have completed the presentation, and there may be some questions, and we have someone that can assist us there. Neil, is that so?
I see on the chat here. You know, it's taken us, you see, Christian, 45 minutes almost.
Yeah.
We get excited when we talk about this.
Yeah, but that's not too bad. 15 minutes above. I was afraid it could be more. But
I see a question here. It says, were IK involved in the project during original installation? If not, why did the client approach IK to develop the repair solution?
Well, the first question is no, definitely. This is this is a big contractor that did. And why did they choose us? They know us from before, and we have done similar jobs for them. So in a way, I think we have a pretty okay reputation for being a company that can deliver bespoken solution or in an agreed time manner, and almost agreed cost as well, because this is what we are specialized in.
And I have another question. Did you use FEA for this task?
Yes, definitely. The analysis done on that, the system response was a very advanced calculation. And we use it for the clamps as well.
And a couple of questions from the same person. Did the client require this to be qualified, and was there a requirement for a hydro test after the installation?
Well, there was a hydro test in the FAT, and it was qualified. I mean, we did both analysis, we did the FAT, we did SIT in a pod where we did it with an ROE before. So it was quite a qualification process for this solution, I would say.
And what about the hydro test after the installation?
Yeah, I must admit, I do not know the details, but it was pressurized, but I'm not sure how high pressure, because you have to pressurize the entire line. Maybe someone else could answer that, because I'm not sure.
Yeah. Okay. Another one. What was the timeline? By Peter Svart.
Yeah. Well, what should we say, boss?
Since we got contacted first, I'm pretty sure it was, am I allowed to say that was about May?
Yeah, it 2000. Was end of May 2019.
2019, right. So there was a temporary solution, and then there was a permanent solution. Permanent solution was finished sometimes in June last year.
Yeah, but I think it's fair to say that we did this stepwise, because we were doing the temporary solution and installed it and proved that it was possible to go down with such tools and do it. So then I think late October, we got the green light to continue.
Yeah, the first operation went from being actually contacted in end of May to finalizing installation in October. Yep. So all this being built, tested, verified, qualified, offshore operation finished in October. Okay. Again, question: how long did it take from the contract award to install temporary repair, and the same for permanent? Okay, so we just basically replied the same question. Really interesting. What way was the clamp, and how is it lifted onto the repair location? So I can respond to that one, because when you say clamp, you're probably talking about the compact integrity clamp, and that clamp is, if I remember right, but we are talking about maybe a couple of ton weight, right, Christian?
Yeah, just
Yeah,
hold the line, please. I'm reading some other questions here.
yeah, reading question.
Yeah.
I don't know which clamp this gentleman is referring to,
No, but I
but
think the answer is that, I mean,
no, I was,
it's being lowered directly from the vessel with, I think, I don't
yeah,
know how they, if they have some constant tension or if it's, but it's, the water there is calm. So actually it was possible to put the clamps and equipment directly onto the location, directly with a line to the boat 1500 meters above. So
yeah,
that worked
because
very well.
the current is very, very low down there at this depth, and just with the heave compensated crane, it was basically no problem to install the clamp. So very little movement, very controlled. You have ROV handlers controlling it. So yeah. Okay, next one. How was avoided the enter of seawater in the pipeline? The pipeline is a gas pipeline or liquid pipeline?
It's well flow, so it's both actually. And so inside, I think there's both water and gas and oil. And the temporary clamp sealed off to a certain degree. Actually, what we found was that there was another leak path, so that didn't actually work as intended. So I think the client managed to get quite some methanol into the system, but actually we do not know all those information because we didn't really sit on the top of that.
No. And another one, may I know the total time required from the first time the problem was discovered until completion of the pressure test post clamp installation? So there's the timeline. So as it was done in two phases.
Yeah, but the total timeline is 1 year. And of course, it could have been done quicker, but the client set it for a stepwise operation. And of course, we were severely hit by Corona.
Yeah.
I mean, it was so difficult. We had to go down there to Africa, and the guys had to sit in weeks in isolation before they could go out. So I mean, without Corona, it could have been quite some faster, I think.
Yeah, and you always have to have in mind this very comprehensive um, testing program and detailed planning, which again sometimes cannot be avoided. Uh, but yeah, we've worked on shorter notice as well and less qualification before. Thank you for the presentation. What sort of timelines are we looking at here from start to finish? Okay, so now we are, say, start time is when the crack was found. Okay, that information we don't really know, but we can only tell you since we're contacted. So that's what we will be talking about. What's the maximum working pressure of your clamp?
We have been up to 500 bar on other 600 maybe. It's really
Yeah,
not any limits because we can put on very hard packers.
yeah,
We can set them, but you know, we need to have a setting pressure, which is about 1.3 to 1.5, the operational pressure of the pipe. And then of course we may over
collapse the pipe.
Yeah, so it is, but we have test pressured up to 3, 4, 500 bar, 600.
Well, yeah, we've actually tested 1,000 bar, but you probably don't even know about this. We didn't want to talk about it, but we are most likely always looking in other kind of a limitation. It's not the clamp. The clamp can seal whatever you can build it, but the other is degraded pipe and collapsing the pipe. That's where you should be looking at, in my opinion.
Yeah, but the pipe is a part of the clamp when you have repair.
Yeah.
I see an interesting here, and that is if we could deliver a clamp like this with a test port.
But can I think there's some questions here I don't want to skip. Is that okay, Christian, if we go
Yeah,
one
of
by
course.
one?
Yeah.
Okay, so how long can the temporary repair be left in place with the structural clamp?
Forever if you
So if you talk about, maybe the only limitation here was the CP. Let's say CP and coating. I don't think we coated the temporary clamp with this epoxy style coating according to NORSOC standard. So we didn't, because we obviously knew it was temporary. So if you think about anodes and all this system, that was probably the only limitation. Materials didn't significantly change in the permanent solution, but the principle obviously did, and there was a structural part added to it, right? The life of the repair was mentioned 25 years. How's the repair monitored for integrity during ongoing production?
Well, it's a part of the inspection program for the entire system, and I guess we left some instructions in the IOM, but I can't really recall. But there will be a need for inspection like all the other equipment.
That would typically not, let's say, be on our plate. So in this case we just advise and instruct, but we're not part of the game afterwards. So we're not inspecting the.
No, but we are giving sort of advice.
Instruction. Yeah, exactly.
Yeah, definitely. I mean, it's important to think life cycle when you design this stuff.
But here's one interesting, and this is coming from a person I know. I missed a bit because of poor internet connection, so please excuse me if you have already explained, but I can see that the pipe seems to have a bend 2-3 degrees at the crack. So did you have to put in something extra to align the pipeline, or was it within the tolerances of sealing clamp? You want to respond to that one?
Well, it turned out okay. We did the tests in the workshop with 2 degrees, and that was within the tolerance, because it's two-parted, so you get 1 degree approximately on each side, and that is within what the slips and the packer can accept. And of course, this clamp will also straighten it up a little. I can't recall really how we did it in the test rig, if we kept it straight or if we managed to let it just move. But we could see from the drawings that it would work okay. The problem would be, of course, if it's too much and you can't fit the clamp. But as long as you could fit it, that is how we designed it, then it would work.
Yeah. So as Christian is saying, I remember this exercise even in a 3D model and further on in the testing. If you had a bend that was like too much, you wouldn't be able to close the clamp and slide it on. It would just start clashing right away there. But on top of that, so we did test with the bend like this. We made a special test rig where we welded 2 pipes at that particular angle that we had subsea scan. But on top of that, the marine contractor have lifted the pipeline several hundred meters away. So they've been trying to basically lift the pipeline, support it, and basically to prevent it from further sagging, going down into the seabed. And by with that being done, obviously it improved maybe tiny bit. So we measuring the angle down there, I don't think it was more than 2 degrees.
No, it was around 2 degrees. We saw it, but I see the question here: did the client repair the pipeline free span prior to repair work? And they did, but they were very cautious because you didn't want to do as little. You want to do as little as possible with that pipe. You were, of course, very worried about separating it completely. But that was done, and now it's more permanent supported to avoid any further fatigue situation at the location. But I saw one question here, which is kind of good, and that is this local pressure testing. Could we have a test port? And we don't deliver these with test ports. It could have been done, but it would be complicated, so we avoid it. And we focus on the robust design, which means that this clamp will seal as long as you manage to prove that you have put it onto the right location. I mean that you hit the crack.
And you set it with the proper torque.
And you set it with the proper torque. And then we have installed, I think, over 40 of this now worldwide for the last 8 years. And there has not been one single leak. And that is because this is so very, very rough and simple. Other clamps where you may have longitudinal seals hitting the compression seals, you have far more possibilities for do a failure. This packer is robust. You can cut it with a knife if you want. It will still work. As long as you get it onto the location and you have a precise location and you can confirm that you have the right torque in the setting bolts, it seals. So I think that's maybe a little bold and a little cocky answer, but I think after our experience now, we can say it so.
Yeah, and plus, from my experience, all of these test ports that are actually vulnerable point or weak point again on the clamp. So it's potentially sometimes further down the road can be actually issue. Can be.
Of course, we deliver clamps with test port for other.
Yeah, but in different methods where you have double barriers and that sort of stuff.
Yeah, or you have a dented pipe and you want to see that.
Exactly.
But so of course sometimes we use it, but for these special local damage clamps, because they are local, they are for pits, cracks, or very local corrosion. They are not for large extended damage area, then they are not usable. Yeah.
And then from John, what was the length of development for both solutions, temporary, permanent? We talked about this one. So it seems like people are very much interested in how long it takes really to build something, to come up with the idea, build and install. So it's what's the range of your clamps referred to the pipe diameter?
What is that?
What's the range of the clamps with reference to the pipe diameter? So
there is really no. I mean.
Okay, so let's go pick your brain, Christian. Say what's the smallest clamp that we built of this type?
Well, there are 4.
Was a 4-inch?
Yeah, 4. The main part is between 8 and 12 actually. But there is no reason for not delivering to a 36-inch line or to a 2-inch line. It's it can be done for any dimension.
Yeah. So remember this 30? No, it was even 40-inch. Yeah. No.
Yeah,
so, but
I mean, yeah, it's no limit.
It's no limit really. Depends on the space that's outside of the pipe.
And if we are going to show more examples, we would show you some really nasty locations inside other structures where it's impossible to get things in, where you can just put this in and then it will be operated by hydraulics only. The ROV just need to put it in place. But I think
I remember that one. Yeah. So how was the hydrate? How was the hydrate formation prevented by Peter Swart again?
And again, there was. I think they managed to get some methanol or DEG into the system, but unfortunately we can't really answer. We were not focusing on the inside; we were only focusing on the outside.
Although Peter, if you call me, I can explain what happened at least during the first installation with the hydrates. So we don't have control because hydrates are obviously formed from inside, so we couldn't prevent this, but. Would you consider improvements to the compact integrity clamp where a local hydrate test to confirm seal integrity could be carried out instead of full system leak? That's what you talked about. Permanent repair sealing clamp. Apologies, should have clarified that. Probably coming from some previous question. Hold on. I don't want to keep. What weight was the clamp? Yeah. And how is it lifted onto the repair location? Now he's coming and saying Yeah, that's he's talking about permanent repair sealing clamp. Yeah, that's the clamp. What Christian was saying, it was deployed down straight with the lifting set, custom-made lifting set that was made for it straight from the crane. Again, John, was the plan to pipeline damaged location lifted up, or was it dredged underneath for the repairs to take place? Dredged. John,
Yeah,
dredged.
definitely. We didn't want to touch it more than
No,
necessary.
no. Glass fiber reinforced polyurethane. Interesting. Okay. Yeah.
Yeah, but it's not fiber. It's really
It's syntactic, what they call GS, glass syntactic polyurethane. So it's infused glass bubbles, I guess. I don't know much about technologies. Probably most of you in the audience know more. Could the client start full production with a temporary clamp?
No.
No. So we didn't touch up on that topic. So after installation of a temporary clamp, there was another leak path discovered through the GSPU. So therefore, turned out to be that permanent repair was the solution.
Yeah, it had turned out to be like that anyway, but it was kind of disappointing with this leak path. But maybe it should have been expected also, because
Well, it was kind of expected because of the brittleness that we saw. I never talked about this, but how GSPU got cracked. You're expecting it to be more of a like
yeah,
elastic and rubbery, but so based on this brittleness, and later on we were removing the or milling out, we noticed some pockets or air pockets, or might have been pockets created by the gas leakage. So it was expected to be not adhering to the steel. So Stefan Hansen, did the client repair the pipeline freeze span prior to your repair work?
We have answered a lot of these, boss. So I think we are getting there. But I see from another here, do you have experience with pipeline
severe
dent repairs? Yeah. And this is not the right clamp for severe dents, actually. Because if you have a proper dent, then you need to envelope the dent. So we have done quite some clamps over the years over dented and bended pipes. And then we put on an enveloping clamp that is sealing in both ends. So it's not for that really.
Yeah.
Then we have the question above.
Yeah. No, it's Peter, and then you, Peter. Thanks, Peter. We have to reply, as you just said, to Allah Elk Hashan. You can we have so many different clamps in our portfolio, and if you want, you can contact me later, and I can share. Or maybe you can share your problem. We can look and see what the best solution for you is. Next one, did your design of the clamp consider the load case of full separation of the pipeline? Yes, I can see already, or account for 50% structural support remain with the remaining 180 degree of weld that remained along the crack location. So
no, we did not include that 50%. That was the
no,
calculations were done without that.
but we have built several types of test rigs here, and we did the full separation test rig when we were doing the structural or the compact integrity clamp. So that was done on a very big test rig with the, can't remember, was it 200-ton pull load on each end? Yeah, obviously, Christian, you I don't know if you want to go there, but there are some limitations in bending capacity, but
yeah, you can never get 100% reinstate, or you can't theoretically get 100% reinstating of all capacities as their repair location, but in practice there will always be some reductions. And of course, it's not the clamp who is the reducing part, it is the interface location at the pipeline which will get some reductions. But as Boss said, we did a test on a completely separate the pipe and put it on. And then actually this connector works very well as a connector, which so it's actually a connector as well, but that is not, and we have it within the family as a connector, as a very simple and rough connector for locations. So it can be, but so far we have used it for sealing of damages only.
Yeah. And then Virendra, how much of the equipment used was off shelf and or pre-designed, including the temp and permanent arrangement?
I think the answer here is more not exact standard or not, because we are always designing according to known design principles where we have field experience and where we have field proven designs. Then we use our field proven design to adapt to new locations. So then when you look at it, you can say, yeah, this is not off the shelf, but the design is off our design folders. We have a huge folder of previous designs, proven designs that we are always using. Then, of course, we have all the bolts, the torque tools. There are a lot of components that you can buy off the shelf. And as a company, we try to do as much standard as possible. We try to invent as little as possible. We try to make it as simple and straightforward as possible, and that's also why we very often succeed in doing new things with existing principles.
I just wanted to add, like, there's quite a lot of pieces of equipment in this job, you know. So starting from coating removal tool, and then XYZ milling tool, and all those clamps, and then structural reinforcement system all together. So obviously some of it couldn't be off the shelf because it's so location specific. But if you look, for example, coating removal tool, Christian, that was that tool. Many elements on that tool were just picked up from some old. So let's say that you could say was pre-designed, kind of. So just adapted for the location.
Yeah.
But it very much is just a hard work and challenge that we take basically for every job. So that's where we are. That's where we positioned ourselves.
Yeah, so I don't think there is any new questions right now, and I see we have spent quite some time.
Thanks, Paul.
Yeah, and nice to see all these questions and all these names. I hope you guys had a good time. And as boss says, please take contact if you have more specific issues you want to discuss. We are very enthusiastic about these things we are doing, and we really enjoy discussing issues and possible solutions with our clients and others. So yeah, boss, do you think we are ready? Are we? Yeah.
Yeah.
Are we done?
We are done.
Yeah, I hope we managed to answer most of the questions. Actually, the list is pretty long here now, but some of them.
Cheers, Graham.
Yeah, some of them are more like I'm scrolling up and down now to see if we have missed.
No, I think we covered all the questions.
Yeah.
It's thank you guys for joining. We were pretty excited about talking about this. So it's good to hear that we created some effect, that at least you enjoyed it. So
okay, well then we say have a nice day, and we may meet again.